This activity focuses on empirical formula. So a compound has two possible formulas. So it has the molecular formula, which is what we are most familiar with. It's what the actual count of each element in the compound. So for example, like CO2, it tells us there's 1 carbon, 2 oxygen. For like sugar, C6H12. O6 glucose, it's telling us that there's 6 carbon, 12 hydrogen, and 6 oxygen. Okay, so that's the molecular formula, but the empirical formula gives the simplest whole number ratio of the atom in a compound. Okay, so basically it simplifies the numbers within the compound. Okay, so all of these numbers are divisible by 6. So if we divide each of them by 6, we would get we'd get 1, 2, and 1. Okay, acetic acid has this chemical formula or molecular formula, which is 2 carbon, 4 hydrogen, and 2 oxygen. All of these are divisible by 2 in order to get us the empirical formula of C1H2O1. Okay, so even though these two molecular formulas are different, they both have the same empirical formula. Okay, so the same ratio of carbon to hydrogen to oxygen. Okay, so we can use the percentages of the atoms in a compound in order to find the empirical formula. So if we have an empirical formula of a compound that's 25.9% nitrogen and 74.1% oxygen, we can calculate out the empirical formula. So step 1 is to change the percent signs to grams. So here I'm doing that. So 25.9% becomes 25.9 grams of nitrogen. I did the same for oxygen. Then we're going to convert from grams to moles. Okay, so I take whatever I had for the sample, so 25.9 grams of nitrogen times, and then I have to set up the ratio 1 mole over, and then we use the mass of nitrogen, which is found on the periodic table, so 14.007. I divide through and I get 1.85. For oxygen, we're starting with 74.1 grams. Convert it to moles. On the periodic table, the mass of oxygen is 15.999. I divide and I get 4.63. Okay, for step 2, it says circle the smallest answer. We will need to know which one is the lowest in moles for the next part. So for step 3, we're going to divide each mole value by its smallest mole value. So the smallest mole value, which we circled, was 1.85. So for nitrogen, 1.85 divided by 1.85 will give us 1. And then for oxygen, 4.63 divided by 1.85 will give us, when rounded, 2.5. Okay. Here, there's a little note. If you can round to the nearest whole number if the answer has a 0.1 decimal or a 0.9 decimal. So you can either round up or round down if it is 0.1 or 0.9. So just be aware of that if you do get any answers that are close to that. So for step 4, multiply each value by the same whole number until your answers are whole numbers. Okay, so basically what it's telling you is you can't have a decimal as part of your empirical formula. Okay, so because we have 2.5, we'd have to multiply this by 2 in order to get it to be a whole number. And so whatever we do to this number, we also have to do to any of the other compounds or any of the other elements in this compound. So nitrogen, we'd also have to multiply by 2. So here's what we did there. So 1 times 2 would be just 2, and then 2.5 times 2 is 5. So when we're writing this out, we have N2O5, which is here. Okay, on your guys' homework, you won't put them into subscripts. You can just write it as capital N, 2, capital O, 5. For this practice problem, a compound is found to have 48.38% carbon, 8.12% hydrogen, and 43.5% oxygen. What is the empirical formula? Okay, so step one, we're just going to change all of the percentage signs to grams. So carbon will have 48.38 grams. Hydrogen will have 8.12 grams. And oxygen, we will have 43.5 grams. Okay, so step one is complete. Step two, convert from grams to moles. So in order to do that, we have to set up, multiply by the ratio, converting from moles, or from grams to moles. So we're going to use the mass that we find on the periodic table for each of these elements. So for carbon, the mass on the periodic table is 12.011. For hydrogen, it's 1.008. And for oxygen, it's 15.999. Okay, so when we multiply and divide these all out, so for each we get 4.03, 8.06, and 2.72. I rounded to 2 decimal places for each of these. Okay, and then the last part of part 2 is circle the smallest answer. So here was our smallest answer as far as moles of each. So step 2 is complete. For the next, divide each mole value by the smallest mole. Okay, so for carbon, we'll have 4.03 divided by our 2.72. For hydrogen, we'll have 8.06 divided by 2.72. And then for oxygen, just because we're dividing 2.72 divided by itself, it's just going to be 1. So for these others, we'll get 1.5 when rounded and 3 when rounded. Okay, so step number 3 is done. For step 4, multiply each value by the same whole number until all your answers are whole numbers. So we do have a decimal in our answer. We got 1.5 for carbon, so we can't leave the decimal. So we're going to have to multiply all of them by the same number in order to get the 1.5 gone. So I can multiply each of them by 2. Okay, and I'll get carbon will equal 3, this will equal 6, and oxygen will equal 2. So for my answer, and on your guys' homework, like I said, you'll just be doing capital. So we'll have capital C, and then there were 3. For hydrogen, there was 6. Okay, and oxygen would be 2. So this is the format that you would put on your homework. Okay, just because it's much harder on Google Forms to put in the correct format of the subscripts.